Hi, this is Eric White. This is the second screencast in this series of screencasts on XML, and both of these screencasts are in a larger series on writing recursive pure functional transforms of XML. And because I am trying to tell an end-to-end story, a complete story, I am including my basic brain dump of the semantics of XML. So that way, when I am talking about some of the more intricate portions of the transform, I can refer to very specific parts of the semantics of XML, and you'll know what I mean. If you already have a complete understanding of XML, feel free to skip these screencasts. But if you want to make sure that you have covered these semantics end to end, that you understand every bit about the semantics of XML, please watch these two screencasts. As I mentioned in the last screencast, the first topic that we're going to talk about in this screencast is the idea of data-centric XML versus document-centric XML. And it makes sense, we have to define what these two are, because recursive pure functional transforms, these are actually specifically oriented towards transformations of document-centric XML. As it turns out, transformations of data-centric XML, these are actually pretty easy, regardless of whether you do it with link or whether you do it with DOM document or what have you. Data-centric transforms of XML are pretty easy. The ones that require us to put on our thinking caps are these document-centric transforms of XML. And it makes sense, we have to talk about what these are in order to talk about these types of transforms. Let's talk about data-centric XML first. Data-centric XML is XML that has a very regular pattern. It is comprised of information such as customers and invoices and invoice line items. It has a very regular shape. Here we have the customer's root element, and underneath that we have one or more customer elements, and underneath those customer elements we have the name element, the age element, and so on. And this pattern will be regular, that every customer will have a child name element, for instance. In contrast, document-centric XML doesn't have this type of a regular shape. Let's look at a document-centric XML file. This is kind of a pseudo OpenXML word processing ML document. It's simplified an awful lot just for the purposes of making it easy to discuss in this context. Here we have a document that has a namespace of W declared, and in that namespace there is a paragraph element, and underneath that paragraph element there are one or more W:(R) elements, in other words the run elements, and those W:(R) elements, they might have a child element of W:(RPR), in other words the run properties. Here we can see the second run is bolded. And then each run element has a child element called W:(T), and that contains the actual text of the run. One thing about word processing ML is you don't necessarily know what order all of these elements are going to occur. That you can have a document that has a bunch of paragraphs, and then it has a table, and then it has a bunch of paragraphs, and then it has another table. And within that table, if you go down inside of a cell, you'll find a paragraph. And further, you could have content controls in that document, and then you could have a paragraph in a content control, and this could either happen as a child of the body element, or this could happen as a child of the cell element. You could have a content control that surrounds the table, then you could have a content control that surrounds a paragraph in a cell. So there's no regular pattern to the XML. It's kind of unstructured data. So that when we look at this other data-centric XML, this is structured XML. When we look at this document-centric XML, it's unstructured somewhat. Further, document-centric XML can be divided into two varieties. There is the type of document-centric XML that you find in OpenXML, which it has these paragraph elements that contain runs, that contain text elements. In contrast, if you look at XHTML, you'll find that you can have an HTML root element that contains a body element that contains a paragraph element, and that paragraph element contains text elements that are interspersed with start and end tag. So this paragraph element contains as a first child a text node. This ABC here is in a text node. That's followed by a B element, and that B element itself contains a text node, which is DEF. And then we see the end tag for that B element. And then we see one more text element that is also a child of the paragraph. This is called mixed content. This is the nomenclature that we use for this mixed text content that is mixed with text and elements. So OpenXML uses unmixed content. HTML uses mixed content. Another example of document-centric XML that uses mixed content is Open Document Format. It uses mixed content. It doesn't really matter which way you go. You can work with mixed content or work with unmixed content. You just have to be aware of it. And it's sometimes a little bit more abstract to deal with mixed content because you need to be aware in your mind of where these text nodes are and what a text node is. So it makes sense now. We've been talking about nodes in this XML document, and let's define what these nodes are and then talk about what the variety of nodes that you will find in an XML document. Nodes are the things that you will find in an XML document that fit into the hierarchy at some level. So elements are a node that can contain other elements at another layer down in the hierarchy. And as you can see here, there are text nodes that fall underneath element nodes. Interestingly enough, here there are actually also text nodes at the beginning of each one of these lines, that there is a single white space text node at the beginning of each one of these lines. The nomenclature that is defined in the XML standard is that if we have white space inside one of these elements that contains text node, so for instance we could have white space here and here and here, this is called significant white space. The white space that occurs at the beginning of each one of these lines, and this is the white space that gives us the indentation of the XML that makes it easier to read, this is called insignificant white space. So this is actually nomenclature that is defined in the XML standard, that there is a notion of significant white space and insignificant white space. So what are the other types of nodes that we find in an XML document? We've seen these element nodes, we've seen text nodes. Another thing that we have is this XML declaration, and this is at the top of an XML document. And this XML declaration, it has this less than, question mark, and question mark greater than at the beginning and end of it. And in that XML declaration, the less than question mark is followed immediately by the 3 characters of XML. And then there are 3 sort of properties or attributes of that XML declaration. This version equals 1.0 tells us that this XML document is using the XML standard 1.0, and the encoding here tells us that this document is encoded with UTF-8. Encoding is a very interesting topic in its own right. All OpenXML documents are encoded with UTF-8. And at some point in time, I will be talking about how UTF-8 impacts us when we're doing pure functional recursive transforms. But we don't have to talk about it too awfully much right now. Just know that all of the XML documents that you will encounter in OpenXML are encoded with UTF-8. And there is one other value that is sometimes set in this XML declaration, and that is the XML declaration of standalone, and it might be standalone set equal to yes or standalone set equal to no. And the OpenXML standard And the XML documents that you'll find in OpenXML documents don't pay any attention to that standalone value that you will find in an XML declaration. So now we've seen this XML declaration, we've seen elements. Another node that we'll find commonly is a comment. So we can type right here. A comment in XML is a string that is surrounded with these special patterns of characters. To the left of it is this less than, exclamation mark, dash dash, and to the right of it is dash dash. An interesting thing about this particular pattern is that it also enables us to comment out ranges of XML in a fairly easy way. So let's say that I wanted to, in an OpenXML document, comment out this middle run. I can put a bang dash dash. Now it automatically inserts that dash dash greater than, and I'm going to just cut that out. And then I can go to the end of where I want to comment out that XML, and I put another dash dash. And now with a little bit of typing, I have commented out that middle run in the XML. This is something that you will often find yourself doing when you're doing OpenXML development. You may be in there manually hacking and slashing on an OpenXML document to see how exactly you want the XML document to look after you transform it or what have you, or maybe you're working on debugging an XML document, finding out why it doesn't actually open in Word. So you want to comment out huge chunks of it and see if it will open if you comment out a chunk of the XML. And you use this approach to comment out the XML and make it so that it's not significant. And we've also seen here that we have text over here. There's one other kind of text. We don't see this other type of text in OpenXML documents as such, but we will see it in other places in our pure functional transforms. This other type of text is CData text. So as an example, I could put w:\code and then so I can put anything in here that I want. So for instance, I could put here root and /root, and I could put another element, and this might not even be valid XML. It is completely ignored until the XML processor sees this pattern of bracket, bracket greater than. As I said, we won't see CData nodes in OpenXML documents, but we will see CData nodes when we are writing XML or HTML to be put into a HTML page or something like that. Another type of node that we'll find in an XML document is something called a processing instruction. So if I come over here and I open up test.docx, and here in Word, I do File and I do Save As, and I am going to save it as a Word XML document. And so I'm going to save it as test.xml and save it and close it. And now I am going to drag and drop test.xml onto Visual Studio so that I can look at it. I'll format the XML so I can see it more easily. And you can see up here at the top of the document, right underneath the XML declaration, there is this second line, which is less than, question mark, MSO-application, prog ID equals word.document and question mark greater than. And that is a processing instruction. And processing instructions are used for a variety of reasons in XML documents. In this particular case, this processing instruction identifies this XML document as a Word document. And so that enables Windows itself to know that this is a Word document. And if we were to look at this document in Windows Explorer, we can see that it does have the Word icon on that file. And it knows to put that Word icon on there because of that processing instruction. There are other reasons that people use processing instructions. They're not common, but they do exist, and you'll certainly encounter them at various times in your XML processing. And the last type of node that you will find sometimes in XML is that of entities. What an entity looks like is there is an ampersand in some entity code. So for instance, NBSB, and followed by a semicolon. So this is a non-breaking space entity. There are other entities such as if we wanted to actually put a less than sign here in this text content of this element, we would have to put ampersand LT semicolon. And we could also put some more info, and we can put an ampersand GT semicolon. And now we actually have a less than symbol and a greater than symbol directly in that textual content of that element. And if we're not going to be using a CData element, then we need to use this LT entity and the GT entity to put in our less than and greater than symbols in the text. It's interesting that linked XML for .NET doesn't enable you to work with entities in a very easy fashion. What it does is when you load in an XML document that contains entities, linked XML for .NET actually takes all of those entities and converts them to their Unicode code point or their Unicode value, and that's the value you actually have in the string. And then when you serialize it, it actually serializes it as that Unicode value. And if you want to serialize entities, you have to do a couple of tricks using linked XML. We'll talk about those later on when we are writing a transform of word processing ML to HTML, where we'll actually need to serialize some entities. Because this was the area in which I wanted to apply the LTXML.js library, in other words, the linked XML for JavaScript library, I built entities right into that library so that you can instantiate entities and serialize those entities in a more easy fashion. We'll see that also when we write our word processing ML to HTML transform in JavaScript. So those are the sum total of all the types of nodes that you will find in an XML document. There are elements, there are XML declarations, there are processing instructions, there are comments, there are text elements, and as a subtype of that, there are CData text elements, and there are entities. And that's all there are. Those are the only types of nodes that you will find in an XML document. Key point about this is that attributes are not nodes. Attributes are just attributes on an element. They don't comprise a node in an XML document. So there's something called an infoset with an XML document. The idea of an infoset is it's a fancy way of saying what really does this XML document contain? What really are the qualified names of the elements and attributes? And what really is the content of those various elements and attributes? There are two documents that can have different serializations, but in reality have the exact same infoset. So for example, here I have a little XML document, and this XML document has a single root element with the name of root, and this XML document has a default namespace of http://www.ericwhite.com, and that means that this root element is in that namespace. And here I have another document, and this document has that same namespace but defined with a prefix, and the root element is in that namespace because it uses the prefix. So we would say and can say that these two documents are precisely semantically equivalent. They have the exact same infoset. It doesn't matter that they are serialized with different prefixes. It only matters what are the fully qualified names of each of the elements and attributes in this document. And as we mentioned before, this namespace declaration isn't really an attribute. It's just part of the namespace declaration. So this document and this document have exactly the same infoset. So what else is in an infoset? Well, one thing that's in the infoset is the XML declaration up here at the top. That's part of the infoset. It actually has semantic meaning to this XML document, indicating what version it is and what the encoding is and so on. The processing instruction that we find, for instance, in this test.xml, this processing instruction that we find up here at the top of the document right below the XML declaration, that's also in the infoset. One small point, that processing instruction, it kind of looks like an XML declaration, but it is not an XML declaration. It's something completely different. The XML declaration has the less than question mark XML and only occurs at the beginning of a file. And the processing instruction has a less than question mark and something else other than XML, and it occurs at other places in the file. Another thing that is in the infoset are all text nodes. So for instance, this text node right here, that's in the infoset. If this text node had a different value, then it would change the actual semantic content of this XML document. And it also follows that CData nodes are also part of the infoset. And also entities are part of the infoset. So when we look at a document that has an entity, as in here, these entities are part of the infoset of this document. So what is not in the infoset? Well, one thing is this comment, that's not in the infoset. The comment has no semantic meaning to the contents of that XML document. You can throw away the comment and the XML document will have the exact same semantic content before you threw away the comment. Another thing that isn't part of the infoset is whether or not an attribute uses single quotes or double quotes. So for instance, here I could change this to single quotes and I have not changed the semantic content of this XML document in any way, shape, or form. As I mentioned, whether a namespace uses a prefix or another prefix or the default namespace, that's not part of the infoset. There's another interesting small point, which is in XML, you'll see something here, which is you'll see something called a self-closing tag. So underneath this root element, I could have a child element, and I can have a /, greater than, and this is a complete element declaration, and it's an element that has no child content. Now I could have also here an attribute. That's okay to have attributes in an element that is a self-closing element. But an interesting point here is that if I have an element that is a self-closing element, or I can also have an element that is defined with a start element of child and an end element of /child, and with nothing between them, those two are exactly semantically equivalent. So in this particular case, this first child element with @=1, and it uses a self-closing tag, and this second example of a child element that uses a start tag and an end tag, those two are exactly semantically equivalent per the XML specification. So whether they are one way or the other, that's not part of the infoset. Another thing is that this insignificant white space at the beginning of these lines, these two spaces that are preceding the child elements, that's not part of the infoset either. Now, a couple of points I'm not going to go into detail here. I'm going to mention them, but they're not really relevant to us as OpenXML developers. But it certainly is possible when we've bound a prefix to a namespace. So for instance, here we bound this W prefix to the word processing ML namespace. There is syntax to unbind that W prefix, and then we could then bind that W prefix to another namespace. This never happens in OpenXML. In fact, one of the nice things about OpenXML is that when we have a namespace and we have a prefix for that namespace, we always use the exact same prefix for that namespace. So that means you can get used to seeing these W colon prefixes and know that those are just part of the word processing ML namespace. And one more point about XML is it's also possible to undeclare the default namespace. So if, for instance, you have a default namespace in scope, and then you need to declare a child element that is in no namespace, you can, in fact, undeclare the default namespace, and then the element that doesn't have a prefix will then go into no namespace. And this also is rare, and it's not used in OpenXML. So we don't need to examine it too much. It's kind of a pretty much of an edge case anyway. There are a lot of other topics to discuss with XML in another context. So for instance, you can validate XML using XSD schemas. And in fact, there are XSD schemas defined for OpenXML that you could use to validate OpenXML documents. You can transform XML documents using XSLT, and that's a huge topic in its own right. That would be a screencast with 10 episodes in it. There's also the XPath description language that enables you to specifically identify any particular node in an XML document using a string. And there's other various XML technologies that you can use, XQuery, so on and so forth. But at this point in time, in these two screencasts, we've covered everything about XML proper that you need to know in order to look at and understand OpenXML documents. That's all I'm going to cover in this screencast. In the next screencast, I'm going to give a quick overview of linked XML. This will give you some background information so that when we start writing our recursive pure functional transforms, you'll know what we're using. We're going to use linked XML to write those transforms. We're going to write those transforms both using linked XML for .NET and using the linked XML for JavaScript library that I put together recently. We can write those transforms using either approach. And all of the examples that I'm going to be providing in the linked XML screencasts, I'll be providing all of those examples both in C# and in JavaScript. Thanks for watching. See you later.